Okay, here we go. So this one, 1 over x cubed will look like this. In the first quadrant, x equals 2, x equals 7, and then we're going to rotate that about -1. Okay, so if we want to get washers out of this, we're going to do vertical strips. Typical strip will be vertical like this. And all right, so if I can see if I can draw. So when you rotate that region about the line y equals -1, you're going to get something like this. Uh-oh. Didn't make it big enough. There's going to be a hole there. And then, okay, that's what you're going to get. So this is the original region. That. And when you flip that around y equals -1, you're going to get this, like, roll over the hole in it, or like a nut. So it's like a nut, like a with no threads in the middle. Okay. So then, when you rotate the strip, you'll get a washer. So we're going to add up a bunch of those. Okay, so we're going to add up a bunch of those. So we're going to have the volume of the washer will be pi r outer squared delta x minus pi r inner squared delta x. So this is the whole thing, the whole pancake, and then minus the little pancake where the hole is. And so what's the outer radius? The outer radius is from here to here. And this is our y equals 1 over x cubed. So how do we define that outer radius? Yes, it's going to be the y coordinate plus 1. So it's going to be y coordinate plus 1. Squared delta x, and then the inner radius is 1. It's just always 1 because it's from -1 to the x-axis. And then you're going to integrate. So we're going to integrate from. So the first we're going to integrate from left to right or top to bottom. Left to right. The first one is at the left side is at x equals -2. That's the first washer. And then we're going to stack all the washers vertically across, and the last washer will be at 7. And it'll be this. It'll be pi. Oh, so then the y is our 1 over x cubed. 1 over x cubed plus 1 squared minus pi, basically, dx. Questions on setting that up? Yes, sir?
I did that, and like I went to tutoring center too, and like the answer just like didn't come out, and I think like a few other people had the same problem.
So you got an answer for this, and then when you put it in, it still counted it wrong.
Yeah.
Well,
3 people at the tutoring center checked it.
Gee whiz, opening all these things here. No, no. Okay, what do I want to open? I want to open this. There we go, okay. So we went 2 to 7 of, so we'll do pi times on the outside, 1 over x cubed. Well, let's just see if mine works. It's 1, and that's squared, minus 1, parentheses. So did I do that right? Pi times 1 over x cubed plus 1 squared minus 1. I think that's right. So I think it's 0.74082. What's that? Huh? So I had the pi's here. So the pi's there. And I just factored it out. I think I got it. 0.740882. You'll be so mad, right? So I don't know. It worked for me. So I'm happy to sit down with you and look at it. Yeah.
When we're doing these, do you want us to do the integral on our calculator or actually take the anti-derivative?
Well, of course, you would be responsible to know how to do this by hand.
Okay.
But I can't stop you from using a solver to do it. But you're absolutely responsible to know how to do that by hand.
So like on a test, you'll want the steps.
I won't be testing this on a test anymore. Right? This is a super easy integral. So, yeah. So, yeah.
Give it to a pre-calc student.
What's that?
Give it to a pre-calc student and see if it's super easy.
Right. For us, it's super easy.
Oh, yeah. Take it to the tutoring center.
There you go. Okay. Okay. Yeah. So if you, I would be curious to work on that. Sure. Who has his headphones in now? Okay. So let's start the new stuff here. So So last time we started with this one. So let's draw this one again. Take a different take on it. So there was y equals 0. That's this the x-axis. X equals 8. Y equals x squared. And we rotated about x equals 8. Oh no, x-axis. So what I want. That's what I want. Okay. So that region is there. That's the region. And last time we said, okay, if we make horizontal strips and we rotate it about x equals 8, we'll get a pancake or a disk. But what if we instead did vertical strips? So what if I took a typical vertical strip in this region? So again, we're going to get this this Hershey's Kiss thing. Just doing so good there until the end. Wow. Hard. There we go. Okay. So this is the solid we're going to get. So what kind of element then, if I start with a vertical strip here in the region and rotate that around x equals 8, what kind of thing will I get? So when it's 180, it will look, when it's at 180 degrees around, it'll look like this. So imagine that thing coming out of the board and back to the screen and then behind and rotating around, right? So what you get is a cylinder, but it's like it's a shell. It's not a solid cylinder. It's just the shell of a cylinder. that. So all of them together to form that solid, they're like one inside the next, right? There's like one that's tall and really has a really small diameter or radius in the middle, and then the next one is a little bit bigger and it encloses that one, and then each one as you move out is enclosing the one from before, and then the last one is real short and the widest, the shortest wide one that encloses them all, okay? So we call, these are shells. So this is called cylindrical shells. So what's the volume of that thing? What's the volume of that thing? Well, to see what the volume is, what you want to do is we want to cut it. Okay? These are my very best scissors. Pretty good. Okay? So we're going to cut it. Okay, so we're going to cut that shell, and then what we're going to do, we're going to unfurl it, and what do you get? A rectangular solid. So you just basically just get something like this. And that's easy. That volume is easy, right? That volume is easy. It's just going to be, the volume of a shell is going to be length times space times height. Length times. What terms do I want to use here? So width times length times, that's fine. Okay, whatever. All right. So I'm calling the width, I'm calling this right here. And what is our width? So that would be, the width is like this dimension right here. Delta x, right? Or yeah, delta x. It's like the width of your original strip becomes the thickness of the shell. So that's delta x. The length of the shell then is what I'm calling this dimension. And if we go back to the original shell, so what is that relative to the original shell? Circumference, right? So that length this way, right and left, would have come from the circumference around, so that's going to be 2 pi r. And then the height is just the height of the shell, just h is h. So it's going to be 2 pi r times h. Okay, so then we need to get the radius of the shell. So what is the radius of this shell? So we think about, here's the center of it, and the center of that is at x equals 8. And so the radius is that dimension right there. And with all your practice with washers and shells, that should be attainable. How would we write an expression for that radius? So it'd be final. This is a difference in x's, right? It'd be final x, which is 8, minus the x coordinate of our curve. So it'd just be 8 minus x. Don't put x squared, okay? It's 8 minus just truly x. It's not 8 minus x squared, because x squared is y. Okay? You want 8 minus the x coordinate of our strip. So that's why I emphasize. So now we're actually, we're not going to change that into y. We're going to leave it x. That's why you need to, for these problems, that's why you need to know, just be able to recognize an x or y coordinate and know that that's x and not x squared. And then what's the height? So then the height would be this dimension here. What's that height? That's y. But we need it in terms of x. That's x squared. The height is x squared. So the width is the thickness, delta x. The length is 2 pi r, and that radius will be 8 minus the x coordinate. And then the height is y, or x squared. H equals y. Okay, and so then we need to just figure out, so that's our typical volume of the shell. That's our setup there. And so now we just need to know So when you figure out the limits of integrations for these shells, you're looking at the original strip that you rotated. So you just focus on the original strip that you rotated and look at, so for delta x, it's going to be the leftmost strip to the rightmost strip. So what's the first shell? Where the leftmost shell, this strip will be where? 0. So the very first one is the really, really short one. It's the widest. The really, really short shell that's the widest, that's at when your strip is at 0. And then where's the last shell? So then each one is going to be inside the one before. We're moving from left to right. And the last one will be at 8. The last strip will be at 8, and that'll be the really tall, skinny. One. Okay, so it's going to be from 0 to 8 of 2 pi 8 minus x squared dx. And that should give us the exact same value that we did when we did pancakes, because it's the same volume. It's the same volume, so you should get the same answer. Questions on that? Does it make sense? Okay, so let's then, at the end of class, we had this one. Let's work on this one. I sure hope so. Yeah, I think I did. Yes, we are recording. Okay, so now this one, we had, if you remember, we had x equals y squared, x plus y equals 6 on the x-axis, and about y equals negative 2. And we said to get, all right, so then when we rotate that, what do we get? Something like that. So this is like a napkin holder or something. It's got a hole through the center of diameter 4. Okay. All right. So what we did was we did vertical strips, and we said if you do vertical strips, you get washers, but you have to do 2 integrals because there's a typical washer over here on the left, whose outer radius is defined by the curve, and then there's a typical washer here on the right, whose outer radius is defined by the line. So what if we did horizontal strips? What would happen? So if we did a typical horizontal strip like this, and we rotate that around y equals negative 2, that'll come like this. And we'll get shells. but there'll be the other orientation. There'll be like they could on the ground, like they could roll. Other flip 90 degrees from the last example. Okay, so then that will look like this. Typical shell. So that's what our shells will look like. And so the volume of the shell, again, will be length. So 2 pi r will always be the length when you unfurl it, times the height, times the thickness. What will the thickness be in this case, delta x or delta y? It always goes back to your original strip, delta y. Okay, so we just need to figure out the radius of our shell and the height of our shell. So height now is horizontal, right? The height of our shell, this is the height. And then the radius is up and down. If we have the radius and the height, then we got it. That'll be the volume of this shell. So the radius of the shell is like this. From the center of the shell out to the strip. So what will that be? 2 plus y, right? 2 plus y is going to be that radius. Y coordinate is the distance up from the x-axis, and then you're going to add additional 2 for this rotation around y equals -2. So that's going to be 2 plus y. There's our 2 pi r. And then what's the height? What's the height of the shell? That's this dimension here, from here to here. So that's a change in what? That's a change in x. It's going to be, that height is going to be like x2, not x squared, x2. And x2 is that the curve or the line? I heard both. So yeah, the x2 will be this dimension here, the line. Minus x1 will be the x for the curve. And that's here. And we need to get those in terms of y. So it'll be v equals 2 pi times the radius, 2 plus y. x2 was the x value for the line, which will be 6 minus y. And x1 will be the x coordinate in terms of y for the curve. Y squared. That's already given as x, right? X equals y squared. Setup work. Got it. So then the volume of this thing. So then again, you're looking at the strips. So now it's this delta y. You're going to look in the region. You look at the lowest strip in the region up to the highest strip in the region. That'll get you all your shells. So at what y coordinate is the lowest strip in the region? 0, right? It's right here. It's the widest. It's the one with the greatest height and the smallest radius. Yeah.
Why did you get x2 minus x1 equals 6 minus y minus y squared?
x2 is this x coordinate defined by this line right there. You see that? That's x2 right there. So that's defined by the line. And that's our line x plus y equals 6. So x is 6 minus y. And then x1 is the x coordinate defined by the curve. So to get the height of the shell, it's going to go from the curve to the line. See that? So the x coordinate on the line minus the x coordinate on the curve. Is that better?
Yeah.
Okay. All right, and then so then we're gonna, since we're doing shells that are this way with delta y, we're gonna look at the first strip in the region, which is here at y equals 0. That's the innermost shell with the greatest height and the smallest radius, right? The biggest height and smallest radius, and then each one after that is going to be wrapped around the one previous until the last one is at whatever that y coordinate is. What do we say that coordinates to that point were? 4, 2. So the last shell will be the one with the greatest radius and the least height at y equals 2. And that will be around all the rest. And it'll be 2 pi, 2 plus y, 6 minus y squared, dy. So then we'd have to multiply this out. You'd have 6 terms. You combine like terms, and then easy. It'll be just a cubic polynomial. Okay, questions on setting that up? Did I lose you?
Just your selection of the height is kind of
The height?
like why is it up
The height is here. So the height is defined of these shells is defined as the bottom of the shell is defined by this curve, and the top of the shell is defined by this line.
there? So like you're drawing, you think of it laying down.
Because of the way the shells are oriented, the height of the shell is left and right. From the bottom circle to the top circle, that will always be the height. Yeah, because your original strip is horizontal. Yeah, it's always going to be the height of the strip. The height of the strip. Is there another question? Yeah.
You expand on the radius is 2 plus y.
Sure. So the radius is going to be from your center here of rotation, right, all the way to the strip. And so from the x-axis to the strip is the y. That's just the y coordinate, and this will always be 2. Negative 2 to here will always be 2. So it's 2 more than the y coordinate of the strip. Does it help?
Yeah.
So always go back to the strip.
Yeah, so all these dimensions are always about the strip that you, before you rotate it. That's right. All these dimensions come about by looking at the original strip before you rotate it. Yeah, that's a good point.
So can you get away with not doing shells, but do it the long way? I gotta see when it's longer to do the 2 sides. But is there ever a time where you just can't do it? You always need to do shell.
Yeah, there would be situations where, yes, there would be situations where like a washer or disc would result in an integral that you can't do. It's like it doesn't have an antiderivative, but shells would. So yeah, so you have to know both.
How would you recognize that situation?
What's that?
How would you recognize that situation in which you could
You would get a integral that you can't do. Yeah, you wouldn't recognize for just before you started. But so in general, like in a question like this, in general, the most convenient thing will be the one that's just one integral, right? So if you do washers, you have to have 2 integrals because you have the 2 different washers with the radius of the curve and then the radius defined by the line. So you're just, as a rule of thumb, do the one that's going to give you 1 integral. Yeah. Okay, so you guys practice, and I have lots of homework to give back. So any questions before I set you loose here? Okay, try.
Is this 7.3 or 2 stuff?
I think it's 7.3. So this is relatively easy. Should be. Okay, go. I even gave you the picture. Bonus. Oh, just set it up, okay? Just set up the integral, okay? Just set up the integral. Malik. They're all yours. So don't look through the stacks.
Is there another problem?
What's that?
Is there another problem?
Oh, yeah. Okay, this one. Let me do it.
Well, that's like, I did.
All right, so this is one you don't want to do washers, okay? You definitely want to do shells here. And you're going to have shells that look like this.
You can't do that.
You could, but you'd have to figure out what this is, x in terms of y, and you'd have to do two different ones. You could do washers, but you'd have two separate ones. So, good example for your question. Do shells. Okay, so that's the worst shell I've drawn all day. And it's going to be 2 pi r h delta x or delta y? Delta x, what's the radius of our shell? The radius of the shell, we're rotating about the y-axis. X. Just x. Distance from the y-axis to our strip. Distance from the y-axis to the strip, just x. Because we're rotating about x equals 0. So it's going to be 2 pi x. The height is just y. So it's going to be 2 pi x e to the minus x delta x. That's the volume of a typical shell. Yes, sir.
Why is it x and not 2 plus x?
Because you're not rotating. If it was it would be 2 plus x if you were rotating about x equals negative 2. But you're rotating about the y-axis. So when you rotate that strip around the y-axis, the distance from the y-axis to the strip is the x-coordinate on this curve. It's because you're rotating about x equals 0. You're not rotating about x equals. If you're rotating about x equals negative 2, then yes, it'd be 2 plus x. But the axis of rotation is simply the x-coordinate, distance from the y-axis to the strip. Is it better?
Well, I don't know, because I just see like a hole in the middle, so I thought you guys could.
But it's your radius of your shell. So your radius of your shell here. So the center of the shell, you're rotating about x equals 0. And so it's going to be the distance out to the edge from x equals 0, not 2.
Okay.
And that's the distance from the y-axis to your strip. That's the x-coordinate. Is it better? So it's always where you're rotating about to the strip. So it's going to be, we're going to integrate from 2 to 5, 2 pi x e to the minus x dx. How do we do that?
Move your constant
X e to the minus x. Undoing product rule, or if you learned if you did parts. So either by parts or what we did, undoing product rule. Questions on setting this one up? Yeah.
Why is it x not 2 plus x?
Okay. So that's what he asked. Okay. So it's because you're rotating about x equals 0, the y-axis. The center of your shell is the y-axis. Okay.
Yeah.
And the distance from the y-axis to the strip is not 2 plus x. It's just the x-coordinate.
Oh, yeah.
You see?
Yep.
It's just that the first shell, the smallest shell, yes, the smallest shell starts with a radius of 2. Okay? So that's what you're seeing. The smallest shell of this thing has a radius of 2, but its radius is still the x-coordinate.
Yeah.
And all of those have a radius of an x-coordinate. Okay. Just set them up. Okay, these are harder, but we need the practice, okay? Just set them up. For time's sake, I'm going to give you the picture for the first one. But you have to know how to generate these pictures. Okay, so this is y equals 4x minus x squared. This is x equals 1. This is y equals 3. You're rotating about x equals 1. You're rotating about x equals 1. See how you do. Do shells up and down. So this is really weird. If you try to do horizontal strips and do washers, why is this weird? Because both the outer radius and the inner radius of your washer will be from this curve. And that's trying to solve this for x in terms of y. That's ugliness, okay? You definitely want to do shells on this. You do not want to do washers. Okay, so our typical shell will be like this. And so we'll have delta x or delta y? Delta x. And so it's going to be 2 pi r h delta x. Radius. So the radius is from the strip to the line x equals 1. That's our radius. It's going to be x minus 1 is the radius. The x coordinate of the curve is where your strip is, minus 1, the center of rotation. Height. What's the height? So the top of the height is the y coordinate of the point. The bottom of the strip is 3, y minus 3. So then you're going to substitute in, since you're doing delta x, that y is going to be right there. And then, so the integral is going to go from what to what? 1 to, all right, we got to figure out what that x coordinate is. Is it 3? So it's going to be the integral from 1 to 3 of 2 pi x minus 1. What's what? 4x minus x squared minus 3 dx. Did you get it? If you didn't get it, could you get the next one? So does it make sense? Anybody have a question? Yes, sir?
How did you get x minus 1?
Okay. So do you see how I've labeled the radius here?
Yeah.
So the it's going to be a difference of x's, right? Because it's a horizontal distance, the radius. So the final x is actually where the strip is. So that's x. But then it's not all x. Then it's going to be minus 1 because we're rotating about 1. So that right there is x minus 1.
And the second part of that, how did you get the height is y minus 3?
Okay, because it's the height of the strip, right? So it's the y. This is the y coordinate minus the bottom of the strip is at y equals 3. You see it? How are we doing on the homework? Did it make it all the way? Both homeworks make it all the way? Keep going. Did it make it to that side? Okay, if you want, I'll stay. If you want to work on the last one for practice, I'll stay.
Homework? Are you all shelled or did you figure out
It'd probably be all shells. Where's the other stack of homework over there? This
you just check that you got my name? I think you might not have heard me.
Okay. Sure.
I'll see that.
Sebastian. Katzen. Still here? Katzen? You're out. Still here? No, you're not. Holden, Aaron's not here. Ronnie. You're welcome. Questions?
Can I see my test?
Yeah. Did you come in late?
Yeah, I don't mind.
Never got it in the first place. Maybe it's on the top. Never got it. There it is. That's out of 30. Okay. Who's next?
So when you were doing the example of the shells, you
Yeah.
did it in one instance where it's just a cylinder, but then another instance you did it as like a rectangular prism.
No, they're all rectangular prisms. They're all, you cut it, it's a 2 pi RH every time.
Okay.
It's always 2 pi RH. So 2 pi R is what you get when you unfurl
You
it.
just unfurl
And then
it. So it's
H.
always the same thing.
So I just cut it and show it the first time.
Gotcha.
But then it's the same thing every time. 2 pi R is the length
All right.
and height. Yeah,
Thank you.
same thing. What's that? I got you. Yeah, yeah, I got you.
Do I need to go talk to the deer?
No. So it's probably my. Did you take it to the DRC? Yeah. So it's probably in my mailbox. I just haven't been over there yet. So I'll get to it this week. Sorry about that.
Can we set up something on this? Because I know I took it when I first got into this, like switched into this class, and I'm not really happy getting an 11.
Yeah.
So can I either?
Just remember it. I don't think it's gonna make a difference for you in
Okay.
the end. You
Okay.
seem like you're doing really well. So, but in the end, if that makes a difference, then we'll take care of it.
Thank you.
Yeah. Okay, we doing this one?
So why can't you do that?
What's that?
How come we can't do the normal way with this one?
With this one? Because the outer radius and the inner radius of the washer. Oh, lots of them you can do both ways. Yeah, there's some you can do both ways, but we're just practicing shells, right? So first of all, your picture looks like this. So it's x cubed, y equals 0, x equals 1, and we're going to rotate about y equals 1, and so then we're going to do a horizontal strip, and it's going to be a shell this way. Good, 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 good. So then v equals 2 pi RH. So what is the height of the shell? What do you guys think the height of the shell is? That's from x2 minus x1, right? It's going to be a difference in x's. So what's x2?
In terms of water,
No, what is x2? It's just 1. It's always 1, right? x1 is? It's at the x, which is the x coordinate of the curve. So your height is going to be 1 minus x. Just x. It's just the x. 1 minus x is the.
Aren't you? I think I get it. Because once you have to change x to y.
Then you will change it to y. It will be the because we're delta y. That's right. Okay, and then what about the radius? The radius is from what, y equals 1 down to here. So how would you define the radius? That would be like this dimension here is the radius. Not quite. Final y minus initial y. 1 minus y. So the radius is 1 minus y, and the height is 1 minus x. And then because we're doing delta y, the x you have to change to x in terms of y, which is cube root of y, right? So let's see if my past self agrees. Did we say the radius was 1 minus y? And then the height, 1 minus x. Is that what we said? So there it is. 2 pi times the radius 1 minus y times the height 1 minus cube root of y delta y. And then we're going to go from what to what? 0 to 1. 0 is the biggest shell. 1 is the smallest. I didn't actually set it up, so let's do it. So the volume, total volume is going to be integral from 0 to 1, 2 pi, 1 minus y, 1 minus cube root of y, dy. Okay, and so then you asked, could we do, sure, this would be a fine one for also for washers. Washers would be totally doable in one integral also. So this is an example where take your pick. It's both be about the same amount of work. Your outer radius would be what? 1. Your inner radius would be, what would your inner radius be? 1 minus y for the washers.
Is it correct to assume you can always do shells?
Yeah, I don't
I don't know. I don't think so. But we haven't seen one where you can't, right? Yeah, I never asked that question. So there's definitely situations where shells are better than washers or pancakes, but I don't know about the other way around.
That's what I'm thinking. If that's the case, then just absorb the shells each time instead of having to find 2 right on.
But like if it's just a basic pancakes with not washers, those are the very easiest, right? Those are the very easiest. Other questions?
The height is 1 minus x because like that is changing like as x goes up. That height is changing.
Yeah. So your outer shell is the tallest one. It's at the bottom, and then as you go,
Up x it changes.
yeah, as you have smaller radius shell, that height shrinks to 0. See that?
Thank you.
You're welcome. Have a good weekend, everybody.